Hello guys, welcome back to my channel. And today in this video we will talk about hypothesis testing. So it's a crash course towards the hypothesis testing, and you are actually requested to subscribe my channel, hit the bell icon, and wait for my future videos because I will be making an amazing videos in the future. So what is actually the hypothesis testing? Hypothesis testing is the method to determine whether there is enough evidence to reject a null hypothesis based on the sample data. So I will explain it with the help of the example. For example, I have a population. I will talk about the Pakistan. On that population, I have a hypothesis, or I have a, you can say, an evidence, which means that the average age in Pakistan is 47. It's just an example. So to prove this thing, I will take a sample of data for from the Karachi, Lahore, or any type of city, and I will calculate their average age. If it is equal to 47, so that means that our null hypothesis was good, was right. And if it is right, we will go with the alternate hypothesis. So it is actually the hypothesis testing when we calculate something based on the experimentation, when we conclude something based on the experimentation. In the experimentation, we have two type of hypothesis, which is called one is called null hypothesis, the other is the alternate hypothesis. Now whenever we do hypothesis, first of all we have a null hypothesis. For example, I want to toss a coin. In that coin, I have a head or tail. So I will assume at first that this coin is fair. I want to prove that if this coin is fair or not. So my null hypothesis will be that this coin is a fair coin, and the alternate hypothesis will be this coin is not a fair coin. Okay, so we will do such type of things. These are actually the hypothesis. The third topic is in this regard is types of errors. Sometimes we are facing errors when we are doing a null hypothesis. Just these errors are due to the human mistake. For example, I have a coin, or and I want to check whether this coin is a fair coin or not. So for this purpose, I will take an experimentation. I will toss 100 times a coin. If I am getting more than if I'm getting between 30 to 60 times head, so that means my coin is fair. But I actually got 45%, and my coin was fair. But I said that my coin is not fair. So it is called the type 1 error, when your hypothesis is true and you reject that hypothesis. And the second is actually type 2 error. For example, if I toss that coin, I got a value of 25 times head. So that means that my coin is not fair, because so 75 times I got head, I got tail, and 25 times I get head. But I accept that null hypothesis that my coin is fair. But I accept that hypothesis that my coin is fair. So it is actually called the type 2 error. So in generally said, type 1 error occurs when something is really happened and you reject that. And the type 2 errors is if something is not happened and you accept that. Okay, so these are the two things. So for example, the average salary in a city is 60,000. The average salary in the city is not. It is called the null hypothesis. It is called the alternate hypothesis. Okay, let's move forward. Now what is the steps in formulating the hypothesis testing? So before that, you need to familiarize yourself with few things. So, first of all, what is the formulate the null hypothesis? We first of all assume two hypotheses. One is called the null, and another is called the alternate hypothesis. And the second is called the significance level. Significance level, actually we set a region. On that region, whether our observation false, we will reject the null hypothesis and we will accept the alternate hypothesis. For example, I will explain with the help of example. For example, I will again take the example of a coin. I have a coin, and I which take the 100 observations. In that 100 observation, I select the area. So if my coin, if the observation or the probability less than 30 or greater than 60, then I will say that my coin is not fair. Because when the probability increases from 60%, which means that you will get at 60%, more than 60%. So that means that my coin is not fair. If, for example, if I get the head 65%, so what does it mean? 20 35% I will get the tail. It's not fair thing. So the region which is you can say uh, which is 30 to 60%, and anything which is fall less than 30 and greater than 30 comes in the significance level. Okay, now you understand it's actually the probability of rejecting the null hypothesis. It's the probability of rejecting of null hypothesis. It is the significant level. It is generally take 5%. It's a 5% thing. It is generally take 5%. Then we select a test. So what is it? We have basically 3 to 4 types of testing. We will explain in this video. We will select any type of a test we want to, which we want to do. After that, we calculate the statistics based on a test, and if the p value is greater than alpha, p means, for example, p means the repetition or the observation which falls somewhere. So, which means that if the if my observation falls between 30 to 60% probability, so my p value will always be greater than significance value, and we will accept the null hypothesis, which means fail to reject the null hypothesis means we will accept the null hypothesis. If the p value is less than is if p value is less than 0.05, what does it mean? That for example, our observation falls in 25% or 75%, so that means that our p value is less than the significant value. So that's why in that scenario we will reject the null hypothesis. Now you understand what is actually the steps in hypothesis testing. Make sure to watch the full video so that you can understand even better. Now for let's go with a new example. Whether for example, we have an example of teaching method which can improve the test scores or not. First of all, we collected some of the data. So the hypothesis is that the new teaching method does not improve the test scores, and the alternate hypothesis is that it improves the test score. Let's calculate the conduct the null hypothesis. So this is actually the traditional score. This is the new score. So here I will use one of the important famous library, Skyfi, where I import stats, and in that stats I will actually t-test relation. I will calculate the t-test relation. I will pass the t-test relation here, and in the t-test relation, I will pass two values: traditional scores and new method scores. And after that, I will assigning into t-test and p-value. Now my t-test value is minus 12.06, and p-value is 7.33. Okay, if your t-test value minus 12.7 indicate that there is a significant difference between these two values, because when we calculate the difference is quite high, and the p value, you can see the p value is 7.33 multiplied by 10 ki power minus 7, which means that it is less than 0.05. So we will reject the null hypothesis. Our null hypothesis was that trad- new method does not improve the score, but here if you calculate these things, that our p value becomes so small that it becomes less than 0.05 significance level. So it means that we will reject the null hypothesis, and we will accept the alternate hypothesis, which is called that our things improve due to the new scores. Our marks improve due to the new scores. Now let's move towards some of the hypothesis testing technique. The first one is called one sample t-test. It can be done when you have a population mean. For example, I have a population mean, as I told you, I am living in Pakistan, and the average age in Pakistan is 47. I'm just assuming this thing, and with the help of some sample, whether I want to calculate whether the age is equal to 47 or not. For this purpose, we use one sample t-test. When the mean of sample is significantly different from a known population or not. So does it mean that we have a population mean here, and we want to calculate whether a sample mean is equal to population mean or not? Here x bar is equal to sample mean. It is actually population mean, and this is called the standard error. So here I again import the stats, and you can see that its example is like the example which I explained you, that for example, you have a bakery, and the average age of a cookie is 30 gram. For this purpose, you took some samples of different weight, and now you want to calculate during I have imported the t test one sample. Now I want to compare these cookie weights with the age of 30. So that means that our p value comes 0.5, and t stats 0.65 means there is a slight change your, you can say there is a slight difference between these two values. And the second thing is 0.54. So what does it mean? Our value is zero point 0.5, which is greater than p value 0.05, which means that we will accept the null hypothesis and we will say that the average age, that the average age is of a cookie, the average weight of cookie is 30 gram, is also found in the sample. When we calculate its average, it becomes it equal to 30. So that means we will accept the null hypothesis, which means that the average weight of a cookie is 30 gram in this bakery. Okay, now do you understand? Now let's move toward the second thing. The second thing is means will be calculate the mean of two different groups. For example, I have a two groups. I have a two groups where I have a different age of people. In the first group, I have an age, and I want to calculate the average weight. If there is a difference in these both two average age, S1, S2 are the sample means, and S1 and S2 are the variances. If you don't know about variances, make sure to watch my video which I have done, which I have uploaded it 1 week ago, and there I explain the complete statistics here. So it's a two test sample test. For example, I have a diet A and diet B. So the group A and group B weight loss data, and I want to compare whether the average, or you can say whether diet A is effective or diet B is effective. The effectiveness in that sense that we want to calculate the difference between these two. In simple way, we want to calculate the difference between the mean difference between group A and group B, whether these two means are equal or not. Let's assume it. Here I calculate the relation, and the p value is 0.03, which is less than 0.05. So it means that these two are different. These two are different. These are not same. Always see the p value. If it is actually greater than 0.05, then it means that we will that our null hypothesis is right. And our first null hypothesis, what was, these both two are same, and our alternate hypothesis was these both two are different. So we assume that these both two are different here. And then we also calculate p you can say the paired t test, where we can it is actually related to the past example which I explained you. T-test relation, we find the relationship between these two things, and we find out whether these two things are equal or not. These are actually the examples. When we calculate the means, if these two are equal or not. The main of hypothesis testing is to check whether the observation we are getting is whether we have the observation we already have is right or not. And you can, I will also share the slide. You can check this slide, and you can actually check this slide. And this paired t test is also uh, like the old test which I compared the two means. Here our p value is again less than, so that means there is a difference between these two scores. If it is greater than 0.05, there is no difference. Okay. Now when to use t test and when to use z test. Now there was a drawbacks of t test. T-test can't be used for large purposes. Whenever we have a sample greater than 30, we try to go for the Z-test. We can't go for the T-test. Z-test is also like a T-test. It is used to calculate the. It also, there is a another thing which is called standard deviation. We will generally work mean and standard deviation in Z-test. In the t-test, we will be working with the mean. So when to use Z-test? When we have a large sample, and when we variance, when we have a variance of population. And in the past, you can say when we calculate use the Z t-test, we doesn't have a variance. We only have a mean. But now we will have a variance here. And when the data follows a normal distribution, the sample size is large enough for a central limit theorem to apply. And it's also one of the main reason. If you don't have a I will also make a video on the distribution, different types of distribution, whether I will explain you all these things. But typically you can say that whenever we have a large sample size, we try to go for the Z test. So one sample Z test is actually, let's consider a scenario. Let's say you want to test whether the average height of a student in your class different from the national height. As I explained you, the problem is same, but we will use some other thing. You collected 50 samples. You collected 50 students, and compute their height is age is 122 centimeter. The population standard 6 centimeter. So first of all, we will do the average student in your class is equal to the national average. We calculate the alternate hypothesis, which is equal to 172, and the alternate hypothesis is it does not equal to 170. So for this purpose, we calculate the z-test formula where we pass out the sample mean minus population mean divided by standard error. In the standard error, we have a population standard deviation and divided by sample size. Here we have a z value 2.36, and we have a z value of 2.36, and for this purpose we will use the z table. You can take it from the internet, and in the z table we compare this value. So what this value compares to, so this value actually moves to 1.96, which means that in the z table 2.36 is equal to 1.96, and which is quite greater than 1.96, so we reject the null hypothesis. Wait a second, sorry, I made a mistake. So if we check the z table value for a z value of 2.36, for example I got the z value 2.36, and I have a already significant level of 0.05. So we will compare it with the 1.96. So for 0.05 significant level which we used before, the value of 0.05 is 1.96. So when in the last we compare whether the p value is greater than 0.505 or not, here we will use 1.96. So we will check if the 2.36 is greater than 1.96, so we will reject the null hypothesis. If it is less than, then we will accept the null hypothesis. Now, in Z test, we have passed out some sample heights variation. For example, the same thing we have done with the help of with the help of you can say Z test. The problem we have solved. We have population mean and STD. We passed these values. We were getting the p value, which is called 6.82, which is 6.82 multiplied by 10 to the power minus 12. It is less than 0.05, so we will reject the null hypothesis. And you can see it's a sample, it's a two sample z test, and it is also same as that test, because we will pass the class A heights and class B heights. Two sample is used for when we compare the two categories, and these all the, and we actually you can say first of all we pass this value, these values we calculate the p value. So I will share the slide. This was from today. We have talked about what is z test and what is t test, what is actually the hypothesis testing. I want you to subscribe my channel, to click on the bell icon and wait for the new video, because in the new video I will be explaining you what is ANOVA test and what is chi square test. Okay, bye bye.